Hi, welcome back. This is Simone from Biim.Games. Today we're going to continue with our third course about the card game with a battle grid. I remind you that if this is your first time or maybe you just seen only this tutorial, I've done also other two tutorials. The first one is for a horizontal space shooter in pixel art, and the second one is about tile map, where you can have also a level editor. If you miss them out, go to check them out before continuing with this tutorial here, because as usual I go in order, so start from number 001 and then go up with the tutorial, so you never lack the basics. So aside for this, let's continue with the tutorial, and today we're going to see two things. The first thing is that we want that each player has their own starting point. So player 1 can deploy the cards only on this part here, on the left, where there are these diagonal stripes. And same for player 2, he or she can deploy the cards only on this right column here. So therefore we want to lock these two things here. And the second thing we are going to do today is that we want that to distinguish which card are from player 1 and player 2. To do this, we are going to face the card of player number 2. They're looking on to the left. Normally, as if you remember, the robots we are creating now in our game, they are all facing right, always look on the right side. But to distinguish from the player number 2, we're going to make them look and play towards the left side. So at the moment I don't have all the robots drawn. Therefore, what you're going to see is the numbers are flipping the other way, they're mirrored. But after you put an image, you'll be the same result. So let's see what is the result now. When I take the card, as you can see, this is mirrored horizontally, and I can't put the card anymore where I want. You can see the selector is not appearing anymore. A selector appears only if I can put, only where I can put the card. So only on my starting point. And therefore, if I leave the card here, it goes back. As you can see, the card also becomes small only when it's actually in the area where I can deploy the card. So it's another visual feedback we can have. And when I deploy the card, it will pass as usual. Play number 1, as usual, we've been lucky, we found the robot. It's facing to the right, as usual. He can deploy the card anywhere, only on the starting point. And playing number 2 again. You got to see. Now you get the other robot, and the robot is facing to the left. So it's actually perfect what we want. At this stage, we can still able to move the card as we planned and pass the turn. So nothing changed, only just placing the card and mirroring them. That's what we're going to do for today. Let's get into it, and put this down. First thing we want to do, actually, by the way, also I remove all the disabled lines, and so all the action, all the events that were disabled, I remove it to make a little bit of space clear. We don't need them anymore. The game is quite stable at this point. And another thing I did, I tried to don't use the zoom, because with the magnifier it's a little bit annoying, wasting probably time. So what I did, I just went on the preference of the program, and then I changed here the size of the font. So it was 9, now put to 12. I hope you can see better. The only thing I will need the zoom only to let you know the values on the properties here, but for the rest it's quite fine. I think it's not too bad. Okay, so let's start now. What we have to do, we go inside our usual triple filter here, and we go here where we say if the card is dragging, and we need to add another condition, is all this big chunk of condition. We're going to add another one, and it says add another condition, system compare to values. And now we say tile map. I will write it first and then explain as usual. Dot tile at of this x coordinate is tile map dot position to tile of card dot x, comma, all this stuff here for y. Okay. And we want this to compare to a value, and the value is turn. So what are we doing here? Basically, we want to see that when we drag the card, in addition to see if the selector is inside the tile map, if you remember, we don't want to show the selector if it's outside the tile map. We want to restrict the area where the tile map is visible, the selector is visible, and we want to show the selector only if it's on the starting point of the player 1, if the turn is turn 1, or player 2 if the turn is turn number 2. Now this value here, this formula here, expression, is actually telling me the number of the tile, as we saw on the tutorial for the tile map. So basically, in the tiles we have in the tile map we have many tiles, and they are recognized in numerical order. The first tile 0, second tile 1, third tile is number 2, and so on. And these are the coordinates where we want to compare the tile map. So these coordinates, as usual, in a cell, in the grid. And therefore, we want to see at this point of this coordinate which type of tile there is. So we recognize if there is a tile of a certain type and compare with turn. So if you go here and see inside the tile map, this is our tile map. This tile number 0. Actually, I can show you on the tile map here. Okay, this tile number 0. I hope you can see. Maybe I magnify this area. This tile number 1. This tile is number 2. Then 3, 4, and 5. They are actually currently empty. So 0, 1, and 2. These are the tiles, and therefore that's why I used this tile here in the past to design the starting area of player 1, and this tile number 2 for design the area of player number 2. Therefore, if the turn is not turn number 1, then the player 1 can leave the card only here. If the turn is turn number 2, the player is number 2, I can put the cards only on this type of tiles. That's why the restriction we just did. This will not work if we don't do also copy this block here and copy inside of the drop part. So as a line and 17 in this case. So we had even the same condition at this point. So therefore now it works because the selector is in place and the card will go in place properly. And now I can just show you quickly how everything works. Now we have already see working as was at the beginning of the video, and I passed the turn. The only thing is not mirroring the card yet, but we're going there in a few minutes. So the part 1 is already done. It was quite quickly. I take the chance to do a little bit of fix. Maybe I start again the program. Sorry, I just forgot it. We have one problem here that's happened when we have many cards. Let's see. When I drag a card, these are quite okay going back on their position, but it might happen sometime. Let's place one card, that the cards don't go back on the original position. As you can see, 14 disappear. We don't know where it went. It's under here 21. 21 now came back to this place. 10 went somewhere. See, so this is something we, of course, we can do all in one video. So that's why we left this behind. But we're going to do this. It's a quick fix. We go in the usual event sheet board, and to avoid this card go back on the wrong slot, we need to add here where we have this else another condition and compare the slot, compare instance variable if the slot number is equal to card dot slot. So now when the card go back to the slot, it will go back to the slot that is the slot that we need to send it back. So it's original position. Take a chance to save, and then again we do a quick test. Take all cards here. All this goes back properly. And then let's see, play number 2, play number 1, 9, 17, 18, 2, 23. Everything is working, going back at the on position. So this is fixed. And now let's see the second part of our tutorial. And we're going to work inside this event sheet cards animations, because it's related to the animation part for our game. So let's try to keep things separate so it's easier to track them down if we need to do some changing in the future. Okay, so it's this something that if you have a free version of Construct 2, especially Construct 3, you might have a little bit of problem with, because it will take a little bit of extra events, extra line of code, and therefore you might want to find a different solution, or anyway do it later when you are able to have a full version of the software. But anyway, just to show you something new that is useful for you. You never know when you need these things to use. So I will show anyway. If you don't have the space to do it, just skip this part here. So how is mirroring working? So normally we have here one action we can add for every sprite. We can just say set mirror, and it will change mirror or no mirror, depends on your case. So basically we've mirror the image horizontally. If you want to do it vertically, you have to use flip rather than mirror. So set flip in this case. Now these are basically just a shortcut. What they're doing, if we go here on our layer, on our layout, sorry, you can see that if I select, for example, this sprite here, I can achieve the mirroring, basically putting in a negative way the value, sorry, the size. So now it's 80 by 160. If I'm going to type and say -80, I will flip it horizontally. So it will be mirrored, as you can see. If I do it on for the height minus, it will be flipped, as you can see. Of course, you can have both at the same time. It can be mirror and flip at the same time. So that's what is doing mirroring, and it's actually not a big deal. It's easy to do, so you can do by code, giving the values, or you can multiply by -1 to make it mirror, or you can use the command as we just said before. but we have an issue that's quite annoying for us, in our case, where we have the animation here. What are we doing? When we flip the card, we start with a normal width that is 80 of the card, and then every tick, if the animation back is playing, if you remember, we're going to reduce the width that is originally 80 by minus flipping speed, that is 10. So it will be 80, 70, 60, and so on every tick, until one point we reach 0 or minus 0, and then we change the animation to front, and then set the animation frame, but okay, this is the same thing, not important. Set the animation frame to the robot we need. So when still this active card is 1, the next tick, this is not going to happen anymore, but it's going to happen this, because we change the animation. And what we have, that is from 0, it become 10 every tick, 20, and so on. So it's going to increase by 10 every tick until it reach 80s, and then it's stop. Basically, we just say, okay, the maximum width is 80. Active card is set to -1, and this is not going to happen anymore. Now, this is working for player number 1, but the issues for player number 2 that they need to be mirrored, and therefore need to have all values negative as the width. So basically, when we arrive here after finish this point, and then we have the width that is 0 or smaller than 0, we can just have the same working flow as here of adding 10, because from 0 become 10, 20, while we want actually to become -10, -20 until reach -80. So what we're going to do is just changing this second block here. I add a sub event that bring it up, and then I say, make a check from system, compare variable, if turn is equals to 1. So if this is the turn of player number 1, then if this I bring it down, and this I bring inside, then do this as usual, no problem at all. Now, in case we have a player number 2, so we add the else. Of course, we have only 2 players, so we don't need to worry about 2, 3, 4 as the case, just the turn is number 2, so it will be else. What we're going to do, we're going to copy this and this inside here. But first we change this one. So rather than have these values to increase by 10 every tick, we want to decrease by 10. So we change to minus. Basically we become 0, -10, -20, and so on at every tick. And when we reach one point where the card width is not anymore this, but it's smaller or equals to card width, normally is 80, so we want the negative -80, so minus card width. So if the card is equals or minus equal or less than minus card width, it means you reach the width the actually we want, you can stop. Then set the width to not card width, because card width is 80, so it to negative card width, become -80, and then stop all the thing. And this is done. This is working. It shouldn't be too hard to understand, just a little bit tricky to reach this point, to think about this solution, but now I show you, so it's no problem. So this play number 1, and then we have play number 2, and we have the mirror image. So far so good, but it's not finished here, because what's happening when I'm going to drag the card, see, the card become normal as before. So this is going to work only when we pick the card for the flipping part, but for the rest we need to fix that part as well. And let's go on with the fix. So still again inside the animation part, this we can just collapse, we don't need, and we make a new event, and we call a function. On function set sides If you have construct tree, it's a little bit different, the function, but overall it's the same concept. You should be able to figure out by yourself. If you need help with function construct tree, let me know. I'll make a special video for that, but as I said before, it shouldn't be a big deal. We have another condition here, a card, compare instance variable equals to robot number equals to something. For now we leave it 0. So what we want to, I remember that this is basically a shortcut for us to avoid to do the same check at every point. So use the function is really a shortcut that we can use as much as we want, because I don't want to do all this changing once for every time we need to change the size of the card if it's player 2. So I will show you here when if I filter events for size, we call it 1, 2, 3, 4 times. We call set size, and that's where the issue is. The issue is here because every time we have some manipulation of the card that is not picking the card at the beginning from the deck, we set the size, and when we set the size to 80, if you are player 2, of course, it's not minus 80. So we want to do this change, and we don't want to put an if here at every time of these events to check if it's player 1 or player 2. Therefore, that's why we're going to use the function we're going to call now. So in this function, we need to pick, understand which card of which card we're going to talk about, and that's why we have this check here on the function, because I remember every time you call the function, all the filtering that we have here, it's lost. Every time you call a function from somewhere, it doesn't know from where it's called, because the function can be called from many different points. That's why we need to pass parameters. So if I need to pass parameter, I just write it here some note. If you have a construct tree, of course, you can just define your parameter and change the name of the parameter. From construct 2, you just need only to write a little note here as a memo. It's not particularly a problem, so just keep your mind always ready, because when you're going to put your hands on the code after a long time, you're not going to remember which one is which, so better always to have a note. Normal. Okay, so what are these notes? So we are going to pass 2 parameters here. The first one is the robot number, or that is the value of the card. The second one is the dimension we want to set the card, small or normal. Small because when we put the card on the tile map, if you remember, we set the size of the card to fit inside the tile. We're not going over. So that's why we have 2 different sizes. So now we're going to filter this card robot number with function dot param 0. Okay, so now we say, after we call this function, which card you need to use. You need to use only the card that has the value of a robot number. So it's unique card, you can get wrong with other cards. Then we have another sub event, and then we say function compare parameter 1. This is the second parameter for the dimension. If it's small, then what? Then we're going to get the dimension here, the small dimension. We copy and paste. Then we copy this. We change this to normal. Then if it's normal, the size has to be 80 by 120. Okay. So this function is called every time for every player. So now we need to consider this is a normal condition. These are the size as same as with the here. Nothing changed. It just called the function. But since we have the issue with the player number 2 for mirroring, we add another sub event here, and we compare system, compare value, turn. If the turn is equals to, so it means if we are playing now with player number 2, we need to make an exception, and we say card set with, and I'm going to write first and then we'll explain as usual, -1 times abs of card.with. Okay, so we have two things here. First one is quite obvious. We are going to multiply by -1 the current width of the card. So if it's the turn of player number 2, you set the card to 64, multiply by -1, it becomes -64, and for the 80 it becomes -80. Not problem at all. But then we need also to add the ABS. ABS is absolute, we saw in the previous video. So this is because when we're going to manipulate the card, we don't know at which point we are going to take the card. The card could have already a negative value as a width, therefore negative multiplied and negative, you get back a positive value, and therefore we lose the mirroring. So we need to make sure that this value here is actually positive. So as we did the last video, absolute will make it positive whatever the value is of the card width, and then we multiply by -1, so we make sure that now the card become negative of a width, and this will solve the problem for us. So the only thing we need to do now is just to call the function, set size, and we need to add the parameters to pass. So the first parameter is card.robot_n, so robot number, and then we add another parameter. So parameter number 1 is the dimension, that normal is the most common use. So we just copy this and disable this one, and we do the same here. We paste and disable here, paste, disable, paste, disable. But here I need to change 16, it's a 64 here, not 80. I will change it from normal to small. Okay, and now I'm saving. I'm going to test it. Okay, so this is play number 2. As you can see, 3 is a mirrored, and nothing happened. As always, stay mirrored. I can leave it. Play number 1, robots facing properly, and so on. So nothing changed. I can still move the card as usual. Even moving the card, they're not going to be flipped or mirrored anymore. So after I change it the first time, they always stay in the same position. So that's it for today. I hope this was useful as usual. Thank you once again to everyone that supports me on Patreon, because thanks for your support. I can cover a little bit of the cost of this time I'm spending to create these videos, not only for the tutorial but also for my diary about how to become a full-time indie developer. That, by the way, if you want to do my same path, have a look at those videos. I think you will find them very interesting. Also, for who supports me on Patreon, we are going to discuss in our community about how to create this game, so we can think about the mechanics, give other names to robots and so on. As usual, define the values of how much damage can make a robot, how much can move, and so on. So it will be very interesting to collaborate together, so we can customize the game as you like. And so I have to say also thank you to everyone that doesn't support me on Patreon, of course. You can help me spreading the voice about this tutorial I'm making. It will be very great help for my side, because I don't have much time to promote this video around. So please, I even appreciate more than the like if you can spread the voice about share this video around. It's a really big help for me. If you want to subscribe, of course, you are welcome to subscribe. And so if you have any suggestions, please leave them in the comment, and I'll see you again in the next video. There will be also the new year. So happy new year to everyone. See you soon. Bye.